So we did the add subtract, which is really like combining except for the subtract because we have to switch the sign. And you guys did that with a video last Friday. So today what we're going to do is we're going to multiply and divide by a monomial. So we're going to have to use our exponent mods, and we're going to have to do some order of operations as well. All right, so when we are multiplying through, that 3 in front of the brackets, if there's no operation listed there, that automatically means multiply. So that's like saying 3 times everything in the brackets. So we could write it like 3 times negative 2m plus 3 times 4. We could do that. If you want to write it out like that, you don't have to. I like to draw lines. I like to leapfrog. I like to take my 3 and I like to say, oh, don't forget, I got to multiply it by this. And I got to take that 3 and I got to multiply it by the back one. So I kind of call that leapfrogging. I make sure that I multiply, that 3 has to be multiplied by both terms in the bracket. So if there's no operation stated, we know that it's multiplied. So we're going to go 3 times negative 2m. What's that going to give us? Ooh, what? Negative 6m. Yes. Negative 6m. And then we're going to go 3 by 4. 3 times 4. 12. But there's an add sign in between them, so we keep that. And that's the answer. So sometimes it's easier to write it like this, if it's easier for you to see. Nice and easy. That's going to give me 6m plus 12. But you're going to get really good at this, and you're going to end up being able to do it just by looking at it as well. So that's multiplying through. It's pretty straightforward. Left. So you can leapfrog it through. Again, I'm going to write this one out. So it's going to be negative 2 times negative n squared plus negative 2. I'm putting my negative 2 in brackets just to remind myself that those things stick together. It's not an add subtract. And by 2n. Okay, and then I have subtract negative 2 times 1. And I flip-flop back and forth, and I'm sure you noticed that in the videos. I flip-flop back and forth between negatives and subtract signs, and those things kind to be interchanged, and they matter. So again, I'm leapfrogging that negative 2 by every term in the polynomial. So I like to draw the arrows, it just makes it go right. So negative 2, the invisible coefficient here is a negative 1. So negative 2 times negative 1. Positive 2. So we have 2n squared. And then I have a negative 2 times by a positive 2. What do I get? Negative 4n. And then I have a negative 2 times by a positive 1. So that's going to leave me with a negative 2. Now I got to clean this up a little because I have plus negative signs, and that doesn't look right. So we're going to clean this up a little bit. So 2n squared, nice and easy right there. Plus a negative is the same thing as saying subtract. And then I have subtract a negative. And this matters, we add the opposite sign. So if you have 2 negative signs butting up against each other, that's the same. Oh, not 4. I don't know where I got 4 from. That should be a 2. So I add the opposite sign. Just like here, I changed this to a subtract, but this then became positive. So I'm switching the signs. So this would be my answer. So that's a lot of stuff from the first unit that we did with number sense. And now we got multiplying, and we have our polynomials in there, and I'm talking about coefficients. And remember that coefficients tells us how many we have. of the variable. So the coefficient 2 means I have 2n, and those would be 2 of the sticks if we were using our algebra. Does that make sense to everybody? I'm looking over the crowd, and you guys are like asleep, not making eye contact. This stuff, if you guys are going to go on to intro, like you're going to, in grade 10, you get 2 math classes to pick from. You have essentials math, or you have introduction to applied and pre-cal. We do a lot of algebra stuff in the intro class. So if this is where you're going into the intro class, and even if you're going into essentials, we use polynomials in both places. We use them a little bit differently. We do a lot of stuff in the intro class with this. So if this isn't making sense to you, it's super important that you let me know and we work through it, because if you don't understand it, it's going to be really hard to keep going with it. All right. Okay. So there was a word here that I didn't even address. It's called the distributive property. The action of leapfrogging that 3 into both things is called distribution. And so if I say distribute the 3, that just means to multiply it into both. It's called distributive property because that's what you do with it. But, okay. Multiplication and division are inverse. They're opposite operations from each other. To divide a polynomial by a constant, we do the reverse process. So it's super similar, but we're dividing in, and it has to go into both of these. Just like my leapfrog into the 2, I have to divide the 4 into both of them. So I might write it as 4s squared divided by 4, subtract 8 divided by 4. So just like that 4 was leapfrogged into both terms, in this case the 4 has to be divided into both terms. Okay, what's 4 divided by 4? Good job, everybody. So I have 1s squared. It's pretty straightforward. And then what's 8 divided by 4? Hopefully 2. So I keep the subtract sign and go 2. Did I need to write the number 1 in front of the s squared? I didn't. It's usually invisible, but if it helps you, it's not wrong to write it down. Okay, that's adding and subtracting. I just want to grab a textbook for a sec. But in as well. We're going to add some of our exponent unit in this as well. Okay, so just like before, we have to leapfrog this 3m into here. We have to leapfrog this 3m into here. And we have to leapfrog it into there. Now, if I were using the mathy term, I would say we were distributing the 3m through those, but I like to call it leapfrog. Before I get started, let's talk about invisible exponents. What is the exponent on the m? 1. And this m? Also 1. What's the exponent on this m? 2. Not invisible. It's right there. And does the 3 have a letter with it? No. It could have m to the exponent 0. What do we know about m to the exponent 0? What's the value of that? 1, right? We'll leave that there for a second. All right, so we're going to have 3m times negative 4m plus 3m times 2m squared, subtract 3m. I'm just going to write the 3 here. I put the m to the exponent 0, but I'm not using it. I'm so excited that the extended page is back. Okay, so now we're going to multiply. What's 3 times negative 4? Negative 12. But we're not done. We have m times m. And remember those had invisible exponents of 1s on them? So what's the law if they have the same base, they have both have the same base of m, I'm looking back there, what's the law when they have the same base and we're multiplying with law number 2? What do we do to the exponents? We add them together. So we're going to keep the base of m. Oh, that's not the right color. We're going to keep the base of m, and we're going to add those exponents together. So 1 plus 1 is 2. All right. Moving on. Oops. What is it there? So my add symbol carries down. 3 times 2 is hopefully 6. Invisible exponent on the m is 1. So I keep the base of 1, and I add my exponent. So 1 plus 2. Last one is to subtract 3 times 3. 9. Good job, good job. Minus 9. But I just have an m here. I have nothing to multiply that m by. So we bring this back, where I had m to the exponent 0 there. I keep the base of m, and I add the exponents with 1 plus 0. Hopefully it's 1. So really, if you have 2 numbers and 1 letter, you just keep the letter. And this would be my final answer. So if you have a variable outside that needs to be distributed through a polynomial, if it needs to be distributed through the polynomial, you have to use your exponent laws from the last chapter. Okay? All right, let's add in a division 1. Let's add in a division 1. We'll throw it off to the side here. Added a third term there. I'm not going to do that. I hope you're all writing in the eraser. We're just going to add. We're going to add a variable to this because we're not going to deal with negative exponents until we're in grade 10. You guys are smart enough to do it. Okay, so remember that 4k squared has to be divided into each term. Has to go into each term. So that's like saying 16k to the exponent 4 over 4k squared plus 36k squared divided by 4k squared plus 4 cubed over 4 squared. Okay, you don't have to write it like this if it makes sense to you like this. I find though, as we're just starting out, sometimes rewriting it makes a lot of sense, makes it go a little bit easier. Okay, so you guys all got that copy down? Perfect. Now we're going to divide. What's 16 divided by 4? 4. Okay, now we're going to use our exponent rules. They have the same base. K to the exponent 4 divided by k squared. So that's law number 3. You keep the base of k, and what do we do to the exponents? We subtract them. So 4 minus 2, we always start with the top. 4 minus 2 is 2. And 36 divided by 4. I don't have enough fingers. I do have enough fingers. 9. 9. Keep the base of k, and what do we do to these? We subtract them, so 2 minus 2, 0. And what's 4 divided by 4? Keep the base of k. We subtract these, so 3 minus 2 leaves us with 1. There's one thing I want to tidy up here. What's the value of k to the exponent 0? 1. Anything to the exponent 0 is 1. So the way I would write this out would be 4k squared plus 9 plus k. Because what's 9 times 1? What's 9 times 1? Hopefully it's just 9, right? So there's a lot of invisible math going on. I dropped my coefficient here of 1, and I dropped my exponent of 1 here. So those are some things that I did. So that's how you attack it. That's how you complete it if you have variables on both top and bottom. And if you decide to go the precast